I survived my second COVID vaccine, and so did my husband. It knocked me out pretty good on Friday. So I was not happy there, but it's okay. This is period 2, 3-1, 20. You all are writing that down, I hope. Okay, I got to pull up my notes on this, and then we will. That's not the right key. Definite integral. See if this is the right one. No, that's not it either. Indefinite retest. What did I do with this average value? More indefinite, more definite. That's not it. All right, I'm looking for my answer key because I want to make sure that. Let's see what it goes down the left side. I think I know. Good. Probably. Okay. Yeah, because it doesn't look like I did an updated like PowerPoint last year for some reason. We'll see indefinite. Okay. Fundamental theorem. All right, so I have taken a few things out of order here, okay, because it just made more sense to me to teach you it in this order than in the order that the College Board wanted us to teach it. And we can't see half the stuff I had up there. You're supposed to be on page 203, and we're going to talk about how do you integrate a function. And I can integrate a basic indefinite integral, and I can integrate a trigonometric function. We're going to talk about the trig ones today. There aren't a whole lot of them in the homework because I just couldn't find any good ones in Delta Math, but they will eventually start popping up the further we get into this, okay? All right, so let's see what we can do with these examples, okay? So first of all, let's talk about some notation, okay? And our goal right now is to get up to about example 16. I'm going to see if I can get us that far, okay? And then you're going to finish it up, plus you're going to do another lesson before Wednesday, or another partial lesson before Wednesday. So on Wednesday, we can finish it, okay? Remember, we've got to keep it amped up because in order to get enough finished by the time of our test. And I haven't officially been told this yet, but a little birdie who's in charge of testing from the district office, in other words, my husband said we're going to be in the second testing window, so May 24, okay? And I didn't know if you heard the other rumors that are swirling around, but the school board goes back to the table on March 9th about having us come back to campus. So I anticipate actually getting to meet you if I haven't met you yet before our AP test. So hopefully we'll get to see one another face to face, okay? But you didn't hear that from me, okay? But start planning in that direction. So hopefully on May 24th, it's a pencil and paper AP test. So we're planning pencil and paper, and we're hoping to have, I'm hoping to get you guys done enough for the last week of April and the first week of, you love being home. Well, you won't be at school full time. So it'll be like, probably our first incarnation of it, it'll be 1 day a week. So you'll get some time at home still, okay? All right. There's parts I like being at home, and there's parts I don't like being at home. So, because I miss seeing you guys. All right. You want all days at home? Well, you can do that, but I don't know how that works. So I don't know how that works with calculus. I was good alone too, but I get to a point where I do need to see other people. One other thing that's coming up, just so you guys know, is this Saturday is another AP readiness. So this Saturday, which is March 10th, March 6th is AP readiness, I think. I want to say it's March 6th is AP readiness. Okay. And then what we're going to be doing in the district is March 13. All the Hemet Unified AP teachers, at least from the comprehensive high schools. So Hamilton, Hemet High, West Valley, and Tockwitz, we're going to run our own little Saturday thing. I will give you extra points to come. I'm kind of curious, and we're going to do it virtually, so it's 100% virtual. So I think 3 out of the 4 teachers are going to be there on March 13th in some way, shape, or form. We're all kind of in the same place, so we're going to do multiple choice March Madness. So we're going to kind of get you into some multiple choice APA problems that day for like 2 hours on a Saturday. So I need to understand from you kind of where you're at, okay? Because I know if we go too late in the day, you're already busy doing stuff and you might not come. And I know if we go too early, you'll still be asleep. So tell me, what works better for you guys, like 10 to noon or like 1 to 3? What do you guys think on a Saturday? I kind of think 1 to 3 might be too late because we might, you guys, it's in the middle of the day. You know, too many people are already going by then. Okay, so tell me in the chat what you guys think. I see a bunch of 10 to noon. So tell me what you think, because I will try to, we'll gear it. I think 10 isn't too early to ask you to wake up. I've got 3 people, 10 to noon, 10 to noon. Okay, that gives me a little bit better. I'll ask third period too. It's not mandatory, but it's highly recommended. Okay, I can't mandate you be there on a Saturday, right? But we start doing these things and I start amping up and we give each more practice as we get closer to the AP test. So this is kind of our first initial stab at it, okay? So not mandatory, but highly, highly recommended. If you're wanting to get that 3, 4, or 5, I suggest you show up. Yeah, I know. 1 to 3 it seems kind of late to me. That's what Hemet High suggested, and I'm like, well, let me check. I was going to check with you guys. So 10 to noon. Normally, if it was me, I would run it at like 8:30 in the morning, but I know that that's too early for all of you. And since I can run it from home, I don't have to go anywhere. Okay. Well, I like the teacher from Hemet High, but you all know my feelings on Hemet High, right? No read anything, right? No read anything in my classroom. Okay. I'm having a real struggle because I changed my avatar, but I was trying to make myself a t-shirt that had like something on it for pi, and it wasn't going well. And I kept finding red things, and it really hurts to have something red. All right, so let's look at this and see if we can get through this. If I don't get through it all by 11:45, hopefully we will. Or where I want to be, I will video the ones that I missed for you. Okay, but I'll have to do that later on today. So suppose we want to find f, whose derivative is f of x. So what would it be? So basically, we have at this point done derivatives, right? So we know how to go. We know we have to subtract 1 and divide and move the exponent out front and subtract 1. But the thing is that we have to be able to reverse that, right? So we need to find a function that when I take the derivative, it would be this, right? So let's think about that. If I'm going to take the derivative and make it that, I would need my original exponent to be something cubed, right? X cubed. And then I would need, and that would get me, I think that would do it, right? If I took the derivative of that, so if that's f of x, and I take the derivative of it, it would be 3x squared. But couldn't I write like a 4 there? Or does it have to be a 4? Could I write like a 5 there? Could I write a 6 there? Could I write any number I wanted there and still get 3x squared? Okay, so it turns out there's lots of them that we could do, right? So any of the derivatives that we could find could be equal to the function above. So any of these would work. So the way that we write that in general is we say we've got a plus c, okay? So what we are going to do is we're going to find the antiderivative today, okay, which means the opposite of derivative, all right? So the function f, usually we use a capital for it. That's purely notation. We don't use that capital very often. Is the antiderivative of f on the interval I, if the antiderivative of f prime equals f if for all for all x and I. So basically there's a little bit on notation right here. So the integral symbol is certainly not new to us by now. We saw it a little bit last week, right? I started kind of throwing it in there last week. Instead of writing what function would have a derivative f of x, we write the integral of f of x dx, which is read the integral of f with respect to x. Generally, we say the integral of f of x dx equals f of x plus c. You always have to write the plus c after your integrals answer. The c stands for constant. And it's because we don't know, and there's no way for us with the information we're given in an indefinite integral to get us back to one of those numbers there, okay? Red's pretty, they're just interesting people. I can't handle red because when I went to elementary school, I went to a private little private church school. And I had to wear red corduroy and I lived in the high desert. It was awful. So that was my uniform. It was terrible. So I can't handle red. And then my husband, when we went to USC for the Notre Dame USC football game a few years ago, it was like a sea of red. My eyes literally hurt. It was so much red. Okay, so the integral. So this little guy here, we're going to go to the soft-time column. It means integral. It also means antiderivative. Those words are interchangeable. If you've been going to derivative, if you've been going to the Saturday EP readiness, which I still encourage, and it'll be a lot more comfortable now that we've done this week. Even if he does something completely new, now that you know how to integrate, it'll be a lot easier. Okay, but you've seen integrals before if you've been doing some of those. So basic integrals that you need to know. So that little hashtag means number. Okay, so if you have a number in dx, it's the number x when you integrate, of course, plus c. They're all plus c. You don't want to forget the plus c. When I don't have any numbers on my integral symbol, that's what we call an indefinite integral. That's why we need the plus c. Okay. When we have an x to a number, we do x to the number plus 1 divided by the number plus 1. So divided by the new exponent. And these will make more sense when we actually do some problems. Okay. All right. This one here, when we integrate that one, we would get the number times the antiderivative of f plus c. So whatever that number is. This one here is basically just saying, hey, one of the properties is that we can, if we add up two functions, we can find their antiderivatives. Just plus c. Okay. And typically, if we're talking about the antiderivative or the integral, we make it the capital letter. All right, so here's where it gets funky. Okay. We are going to do the integral of sine of x. So the integral of sine of x is negative cosine x plus c. Now you're all going to mess up on your derivatives, right? Because I just gave you something completely different. Okay. So in derivative world, the derivative of sine is cosine. The integral of sine is negative cosine. Okay, so you got it. You're gonna have to figure out a way to keep that straight for yourself. The integral of cosine, however, is positive sine of x plus c. The integral of secant tangent would be secant of x plus c, because remember the derivative of secant is secant tangent. The integral of cosecant cotangent is negative cosecant of x plus c. Anybody got any guesses? What's the integral of secant squared? What is your brain is going to have to adjust, Bianca. You're going to have to do it. All right. So anybody got a guess on the integral of tangent or secant squared? What's the integral of secant squared? Think about your derivatives, right? What's the derivative? Sine, cosine, tangent. So and then one of the derivative answers should be secant squared. What do you guys think? So what's the derivative tangent? What's the derivative cotangent? What's the derivative secant? So think about those answers and how do I reverse secant squared? What do you guys think it is? Nobody has a guess? You guys are quiet today. All right. In the interest of time, it's tangent of x plus c. This one's going to be negative cotangent of x plus c. You're going to want to know this one, and these two. They come up quite a bit. Okay, the other ones not so much. These other ones here are kind of nice to know. We're going to write them down just in case they pop up anywhere, but they're a little bit crazy. Okay, So the integral of secant is the natural log, the absolute value. I think we proved tangent later on somewhere. Secant x plus tangent of x plus c. And these are all on the front inside cover of your book. The integral of cosecant x is negative natural log absolute value of cosecant x plus cotangent of x plus c. Okay. The integral of tangent of x is negative natural log absolute value of cosine of x plus c. And then cotangent is the natural log absolute value of the sine of x plus c. Again, those ones we're probably not going to see very often, but I put it in there. Okay, just in case. All right. All right, so let's do a few of these. Okay. So when I integrate just a number, okay, I get the number times x. Really what's going on there plus c. What's going on here is really we have 3 times x to the 0 power, meaning there's no x's. Okay, really I am adding the exponent of 1 and then I'm dividing by that new exponent 1. So that's what's really going on there. But it's the shortcut is just put an x after the number. Okay? All right. Let's look at this one here. So I'm going to add 1 to the exponent. So I get x to the 4th, and then I divide by the new exponent 4 plus c. Okay, I'm going to start asking some questions now that we've done a few basic ones. I want to hear everybody in the chat. Okay, what do I need to do to the exponent? So everybody tell me, what do I need to do to the exponent in this? So when I integrate, what do I do to the exponent? All right, good. Good. We're going to add 1. So I'm going to add 1. I get 3x to the 6th divided by my new exponent 6 minus 4x to the 4th divided by my new exponent 4 plus 2x cubed divided by my new exponent 3 minus 5x squared divided by my new exponent 2. What do we always put at the end, you guys? What's always, always, always at the end when we integrate? Tell me in the chat. What's always at the end? I had a lot of, there we go. Okay, so it's always plus C. Nice job. And typically it's a capital C. I know you guys are just typing fast, but make sure it's a capital letter C. Okay. Technically, yes, I could simplify this on like Delta Math probably needs to be simplified. On the AP test, if it's multiple choice, it's got to be simplified. If it's free response, it doesn't. So this one, let's see, I would probably go 1/2 x to the 6th. Those would go away, minus x to the 4th plus 2/3 x cubed minus 5/2 x squared plus c. All right, let's take a look at the 4th one. So I am going to add 1, you told me, so 5x cubed, and then what do I put in the denominator? So what's going to go in my denominator right now? What's going to go in my denominator? Everybody tell me what goes in this denominator. I want to make sure that we're understanding. Okay, we're going to get 3 in the denominator. Minus, okay, we're going to, this exponent's technically a 1. So 1 plus 1 is 2 divided by 2 plus 5, and it's just a number, so I throw an x after it, plus c. Okay, easy peasy lemon squeezy right now, right? We can all do this. So those of us that stopped doing homework like 12 weeks ago, you can start again. Okay, easy peasy. You can do this homework today. Okay. All right. The integral of sine. Now, when we have a number in front of a coefficient like that, we're just going to leave it. So 2. The integral of sine, we said, was negative cosine x, and the integral of cosine is sine x, and then plus c at the end. Done. Okay. All right, let's see who was paying attention, okay, earlier. Let's see if we wrote this stuff down, okay? So what's the integral of secant squared? Because you were all crickets before when I asked you to guess. What's the integral of secant squared? Tell me in the chat. I like those of us that are putting the plus c. So when we do the plus c, we only write it down a one time in the problem. So if I have to integrate like secant and then I have to integrate the secant cotangent, I only put 1 plus c at the end. So this just goes tacked on to the end. But I do like the tangent. All right, when I integrate cosecant cotangent, what do I get? Tell me that in the chat. What do I get cosecant cotangent? Uh-oh. Oh, here we go. There we go. Okay, it's still negative. So it's the one, when we integrate, if the original integral starts with the c, no. So if the answer has a c, it's a derivative. Okay, or it's a negative. So it's negative cosecant of x, and then plus c, and this is just going to go positive. Okay? All right, we're moving right along. Okay. Oh boy, that didn't come out very well, did it? So we're going to integrate secant and tangent. I'm just going to go back up here and look. So the integral of secant is natural log secant x plus tangent x. So we just throw the 3 in front of it. 3 natural log absolute value of secant x plus tangent x minus 2. The integral of tangent is negative natural log cosine of x. So negative natural log absolute value of cosine of x, not c, of x, plus c, make it positive. Okay? All right. I am not going to worry about what's in the left-hand column because I can't read what it was supposed to say. I'm just going to show it to you the Mrs. Ballard way. Okay? So maybe we can figure it out here in a minute. So I need the variables to be in the numerator and I need them to have exponents. They could be fractional exponents, okay? So in order to move this, I'm gonna rewrite this by moving it upstairs. So x to the negative 2 dx. Now it's in a place where I can add 1 and divide by the new exponent. So I'm gonna add 1, which would give me x to the negative 1. I'm gonna divide by negative 1 and then always plus c. Probably that's not what the answer is going to look like. They will likely move that negative exponent back downstairs and probably float the negative in front. So it'd probably be negative 1 over x plus c. All right, I'm going to rewrite example 9, x to the 1/2 power dx. Okay. And then when I add 1, it's going to be a fancy 1. It's going to look like 2 over 2. So I would get x to the 3/2 divided by 3/2 plus c. That's kind of ugly looking, right? So there is kind of a shortcut. Instead of writing divide by 3/2, you multiply by the reciprocal of the denominator. And I will a lot of times just go straight to this, straight to the 2/3 x to the 3/2 power. Okay. Sometimes before we integrate, it's necessary to do some algebra first. So I'm going to start by distributing. I'd have way too many arcs, don't I? To start by distributing that in. So I'd have x to the 6th minus 3x. Look at that, 3x squared. 3x cubed, sorry, plus 2x squared minus 3x dx. I can't remember if we talked about the dx. We may have missed that part of the lesson. The dx, it was representing, remember all the little rectangles we did? It represents the width of the rectangle. So this is basically the height of the rectangle when we were doing Riemann sums, and this is the width of the rectangle. So that when and then the integral is the addition sign. We're adding up all those heights times widths. Okay. All right, let's do it. All right, so we've got x to the 7th over 7 minus 3x to the 4th over 4 plus 2x cubed over 3 minus 3x squared over 2. What do I type at the, or what do I put at the end? Everybody tell me in the chat. I want to know you're still listening. What do we put at the end? Oh, some of us got it capitalized this time. Nice job. Plus C. Awesome work. I'll give you a couple seconds to catch up. Okay, let's take a look at, we got to get through 11 to 16 is kind of where I wanted to aim. Okay, we'll see what we can do with them. So the number 11, I'm going to convert that. So what is my, before I take the integral, what should my new exponent be? Can you tell me that in the chat? What's my new exponent? We've forgotten some things. Oh, there we go. Okay, so let's go back to algebra 2 for a minute. Okay, let me draw a tree. Okay, actually, let me draw the, I don't have a brown one, so we'll draw the trunk as black. There's my tree. Okay, the roots are at the bottom of the tree. Do we remember that? Okay, so whatever is in the root goes at the bottom. So my new exponent should be 4/3. Okay. All right, so hopefully we've done our quick algebra 2 lesson there. Okay. All right, we are going to add 1. What's my 1 going to look like this time? Can you tell me that in the chat? What's my 1 going to look like? Good. Good. So plus 3/3. So I end up with x to the 7/3 divided by 7/3, or we multiply by the reciprocal of the denominator. So 3/7 x to the 7/3 plus c. This is what you're going to see multiple choice answer. Okay. All right, we're going to rewrite again. Okay, so we're going to rewrite a little bit. I don't know what to do with the number 12, so I am going to split it up into 2 fractions, which I'm allowed to do that. So I'm going to say it's x over the square root of x plus 1 over the square root of x. You know what? I don't like those square roots. Let's make them 1/2 powers instead. Oh, and I forgot my dx. Okay, so I know that the exponent on this x at the top is 2/2. I did that because when I am dividing, what do we do with our exponents? Can you tell me that in the chat? When I'm dividing, what are we supposed to do with our exponents? What do we remember? It's algebra. Division turns into what for exponents? All right, we are going to have subtraction. Good job. So I'm going to subtract. 2/2 minus 1/2 is going to be positive 1/2. And then I'm going to bring this one upstairs with a negative. So x to the negative 1/2 dx. So now, and that's a 1, sorry. Should have written tinier. So I'm now ready to go ahead and integrate that. So again, we're going to add 1. I'll do it in a different color. So add our fancy 1. So that's going to be x to the 3/2. I'm going to take my shortcut. I divide by 3 or I multiply by its reciprocal. Divide by 3/2, sorry, or multiply by its reciprocal. Plus, I'm going to add 1, our fancy 1, which would make it x to the 1/2. I divide by 1/2 or I multiply by its reciprocal. Obviously, I would just write a 2, okay? But I'm overemphasizing the reciprocal part, plus c. See, quick and easy today, right? Look at how much we've done already. And we blabbed for a little bit and took a pop quiz. Okay, on example 13, probably what I would do first is I would do a little bit of foiling. Okay, so let's do a little bit of foiling first. So this one, I would rewrite it out as 2t squared minus 1 times 2t squared minus 1 dt. And doesn't matter what variable's in there, we go with whatever variable. Just this thing here and this variable have to match. All right, so 2t squared times 2t squared is 4t to the 4th. And then in the middle, I get 2t squared times -1 is -2t, but I have 2 of those, so it becomes -4t squared. And then -1 times -1 is +1 dt. All right, let's now add 1 to the exponent. So we're going to go 4t to the 5th divided by 5 minus 4t to the 3rd divided by 3. Okay, I'm going to ask a question. When I integrate the 1, what am I going to write? So what's that last term going to look like? I'm not talking about plus c. What is that term going to look like before the plus c? What I write there? All right, we have the right sentiment, but the wrong letter. Okay, so instead of an X, would you like to revise your answer? We're not in X's right now, are we? There we go. Nice job, everybody. It's going to just be a T. And I don't need the one coefficient. Excellent work. All right, now we're going to get into the wonderful world of trig. As you know what I say, it's not a day that ends in Y if we don't do a little trig, right? So I am going to split that into two integrals because my goal is to try to get, if I can get one of these guys right here that we had up at the beginning, if I can get it into one of these, that's what I want. I'm looking for one of these guys to pop up, okay? So sometimes I have to just manipulate the algebra or the trig that's there a little bit. So let's see, if I have, I'm going to split it into 1 over cosine x times sine x over cosine x dx. All right, let's think back to our trig. What's 1 over cosine? What's another name for that? Can you guys tell me in the chat? What's another name for 1 over cosine? Okay, good job. It's secant x. What's another name for sine x over cosine x? What's sine x over cosine x? The good news is we haven't forgotten our trig. Excellent work. Okay, tangent x. And do you see how one of my integrals just popped out? The integral of secant tangent is secant of x plus c. Okay, same idea on these other ones here. We'll see if we can get, we've got like 5 minutes left, so we'll see if we can get these two in to the best of our ability. All right, I'm going to, don't know what else to do. I'm going to go ahead and distribute. My screen just flashed weird, so making sure we're all connected here. So this is the same as saying the integral of the secant, and notice they changed my variable of integration to y. Secant of y, tangent of y, minus secant times secant is going to be secant squared y dy. Again, looks very familiar, okay? So when I integrate secant y, tangent y, what do we get? Tell me in the chat. And I don't need the variable, just tell me, is it sine, cosine, tangent, secant, cosecant? Maybe it's got a negative in it. So secant y, tangent y, what does that integrate to? What do you guys think? Go back and look it up. Look at the last problem even. All right, I've got a couple people saying that this piece is secant, and I would keep it in y. You don't want to change your variable of integration, okay? Secant squared, what's secant squared integrate to? So what's this piece integrate to? Who knows? Well, we've got a few people picking it up. Good, 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 good. Tangent of y. And then what do we put at the end again, everybody? Always, 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 what goes at the end? Ah, yes, plus c. Good job. That's like the new, point and slope, right? It's plus c. Okay. We won't be doing tangent lines for a while, so we can't forget our point and slope, but because we've totally switched to a totally different part of calculus. All right, example 16. I need to use a Pythagorean identity. Okay, remember your Pythagorean identity, sine squared plus cosine squared equals 1. I almost have it right there, right? And this, as far as the exam goes, it won't go above the Pythagorean identity. There's some identities we didn't learn, which the whole week we have after the exam, maybe we'll, or a couple days we have, maybe we'll get into them. If not, we'll do them in BC the first day next year, okay? Because you got to see me dance, right? Because that's a dancing lesson. Equals 1 minus, I did that wrong. I wanted the cosine to go over, not the sine. Let me try that again. So cosine, now I'm going to do the same thing again. Watch. All right, so it's sine squared x equals 1 minus cosine squared x. So I can take and replace this piece with sine squared. So let's do that. Cosine of x over sine squared x. And then I'm going to do something similar to what I did in the earlier one there, like in 14. 1 over sine x times cosine x over sine x. So all I did was manipulate the trig a little bit. All right, what's another name for 1 over sine? Tell me in the chat. What's another name for 1 over sine? I don't think this one works. Oh, yes, it does. 1 over sine. Anybody know? It's not it's not cosine. There we go. Casey's got it. Cosecant. Cosecant. That's what I'm thinking. Oh, this isn't working. It does work. Cosecant. Okay, what's cosine over sine? These are the lesser known ones, right? Cosine over sine. Cosine over sine. There we go, Casey. Good job. Cotangent dx. And again, this one isn't used very often. This is the one I'll put it on the practice, and then I put secant and tangent on the test. You'll see that happen a lot. So when I integrate that, I get negative cosecant of x plus c. Okay? So what you need to do, because I know we're kind of at time right here, okay? What you're going to do is you're going to go in and you're going to finish the lesson.